Soil phosphorus supply status is expressed by soil available phosphorus content. There is a good correlation between the content of soil available phosphorus and the amount of phosphorus absorbed by plants in the current season. The content of soil available phosphorus, determined by chemical method, is a relative index to evaluate soil phosphorus supply capacity and an important basis for rational application of phosphate fertilizer. Next, we will study the determination methods of soil available phosphorus content, which mainly includes 5 aspects: determination principle, instruments and appliances, operating procedure, result analysis, summing up, and thinking. 1. Determination principle of soil available phosphorus. Generally, neutral and calcareous soils are leached with sodium bicarbonate extractant, while acidic soils are leached with acidic ammonium fluoride, or sodium hydroxide and sodium xylate extractant. The phosphorus in the leaching solution of the soil is reduced by molybdenum antimony anti-mixed temperature chromogenic agent at room temperature, so that the yellow antimony phosphorus molybdenum heteropoly acid is reduced to phosphorus molybdenum. The depth of blue is proportional to the phosphorus content in a certain concentration range, and the content of available phosphorus in the soil is calculated by colorimeter. This time we used sodium bicarbonate leaching molybdenum, blue colorimetry, to determine the content of available phosphorus in soil. 2. Instruments and appliances. Choose spectrophotometer for instrument appliances, measuring cylinder, pipette, triangular flask, volumetric flask, cuvette, balance, oscillator, phosphorus-free filter paper, reagents, 0.5 mol per liter sodium bicarbonate solution, molybdenum antimony anti-color reagent, phosphorus-free activated carbon, 5 micrograms per milliliter phosphorus standard solution. The sample is an air-dried soil sample with a particle size of 1 millimeter. 3. Operation steps. The first step is to weigh the soil sample. Accurately weigh about 5 grams of air-dried soil sample with a particle size of 1 millimeter and place it in a 250 milliliter triangular bottle. Secondly, preparing soil leaching solution. Add about 2 to 3 grams of phosphorus-free activated carbon, then add 100 milliliters of extractant. Shake it slightly. Shake it on a shaker for 30 minutes. Then filter it with quantitative filter paper and discard the initial filtrate in a 150 milliliter triangle bottle. The third step is to add color developing agent. Suck 5 milliliters of filtrate into a 50 milliliter volumetric flask. Slowly add 5 milliliters of molybdenum antimony anti-chromogenic agent. Shake and discharge carbon dioxide. Then add water to constant volume and shake well. Leave at room temperature above 20 degrees Celsius for 30 minutes. Note that each measurement should be repeated 3 times to eliminate systematic errors. The fourth step is to draw the standard curve. Respectively suck 5 milliliters of phosphorus standard solution, 0, 1, 2, 3, 4, into 50 milliliter volumetric flask. Add 5 milliliters of sodium bicarbonate leaching agent and 5 milliliters of molybdenum antimony anti-chromogenic agent. Shake and discharge carbon dioxide. Then add water to fix the volume to the scale. The concentrations of phosphorus in this series of solutions are 0, 0.1, 0.2, 0.3, 0.4, and 0.5 microgram per milliliter respectively. Leave it at room temperature higher than 20 degrees Celsius for 30 minutes. Then use spectrophotometer to measure absorbance and record it. The fifth step is colorimetric determination. Calibrate the spectrophotometer with no-zero standard solution. Colorimetric measure the absorbance of the soil solution with a cuvette at the wavelength of 660 nanometers and record it. Step 6. Calculate the result. Using the function formula of the standard curve T, He concentration of the solution to be measured is 0.35037 and 0.35 microgram per milliliter respectively. Then the content of soil available phosphorus is 71.26 milligrams per kilogram by substituting the following formula. According to the National and Soil Nutrient Content Grade Standard, the measured data is 71.26 milligrams per kilogram, which shows that the soil sample is rich in available phosphorus. That's all for this lecture.